Okay, let's start. Today, today's seminar is about intro in PyTorch and deep learning. So, um, PyTorch is the one of the most popular libraries for deep learning, for create experiments with different neural network architectures. And yeah, now we start to discuss why is PyTorch so useful and what main parts are in this library. So when we want to create some experiments with neural networks, we need to define first of all, of course, architecture of our model. So we need to have blocks, different type of layers for create different architectures. Also, we need to have activations and loss functions. All of these blocks they are in PyTorch. We don't need to code develop these blocks yeah, by ourselves. It is really useful and easier for making experiments. Also, we know that we need to define um, some technique for training our models. We use some gradients methods for that, and yeah, I think you hear about back propagation. So in PyTorch, released tool, Autograd tool, and this tool helps us create helps get different gradients and make a step of optimization process automatically. Yeah, and it is a really cool tool because if we start to use NumPy for our arrays, for our models for creating neural networks, we always need to care about how to calculate gradients on each layer. Yeah, it is not easy process. So also this library allows us use GPU, and this can make our training process significantly faster. So, how you know now neural networks are using for solving different types of problems in different using different data. For example, for solving problems, these images, texts, and audio, and there are some libraries for make preprocessing and some transformations for each data type. Yeah, please pay your attention to Torch Vision, Torch Text, and Torch Audio libraries too. Also, I want to mention other two cool frameworks, PyTorch Lightning and Hugging Face. Today we will develop training loop and validation loop from scratch by ourselves, but for that better use PyTorch Lightning. And also PyTorch Lightning can help you to scale your solution, your training process for many GPUs. Yeah. And Hugging Face contains various pre-trained models, and you can make experiments these pre-trained models, and you don't need to learn from scratch. And yeah, we in the some of the next classes we will look how fine-tune the pre-trained models. So it is about why now PyTorch is so popular for making experiments with neural networks. The main block in this library is a tensor. Tensor is a multi-dimensional array, really very same this NumPy array, and you can use PyTorch tensors in many cases, like NumPy arrays. These same methods, these same functions. So, but tensor we can, but using tensor we can transfer it to GPU, and yeah, for make computation our computations faster. Okay, now we will see how create tensors and how we can use this type of data. Yeah, tensor in PyTorch, it is a class, and you can initialize your tensor in this way. Now we created one-dimensional tensor, but of course you can use two-dimensional, three-dimensional tensors for your needs. You need to understand that each element of a tensor is a tensor too. For example, if we get element from this vector by index, for example, by 0 index, we get a tensor. If we want to get value, we need to use method item. So, guys, can you give me examples of real-world tasks, real-world data, and what dimensions for this task we can use? Please feel free to start to talk. give me examples of data types and tensors of what we need. Okay.
Can you
yes.
repeat the question, please?
Okay. Yeah. There are a different. There we can use different type of tensors in PyTorch. These different dimensions, and for example, we can create one dimensions tensors like vectors, or two dimensions tensors like matrices, and other types, other dimensions too. So please give me an example of real world data, and how dimensions we need to use for this type of data for coding, for represent this type of data as tensor.
So, for example, we can use it in computer vision, where we can represent image as a 3D vector. Like,
what kind of images we need to represent as three-dimensional tensor?
for example, usually images are represented with tensor shapes, so it includes height, width, and maybe channel, and then we can use the RGB image to represent the tensor as a shape. So, for example, if we have a 2 by 2 tensor, we can have different values for different rows, depending on the RG, like these values would represent the RGB color values.
Yeah, we can use three dimensions tensors for colorful images, and two dimensions tensor for grayscale images. Yeah, and in today's class we will solve the task with these grayscale images. So how we can represent a text, for example?
Like a pixelated text, we can like assign 0 or 1 value to each pixel on the screen and use that to encode using maybe CNN or something. So the
Yeah.
0 would be the empty pixel and 1 would be pixel with like the gray color or something.
So no, now I'm about text, not about image. Yeah, just about words, sequence of words, not about images of text. So okay, we can represent as one dimensions vectors, for example, for classification tasks, or um, for generation process, we needed to represent each word as a vector, but all text we can represent as a matrices. So I just can show that our representation type really depends on task what we want to solve, not only about data types. So, okay, we can use a different type of data, data for initialized our tensors, and depend on what type of data we want to wrap using tensor. The tensor, the types of tensors will change. For example, now we used list these integers for creating tensor, and in this case we have a type of tensor, long tensor. If we created based on list these floors, these floor numbers, in this case our tensor will be double tensor. So, and of course you can give a type of your data in constructor for tensor, and also you can use that for creating different types of tensors, and you need to remember that you can use the method type for get type of tensors, but you can use the fill d type for get type of data what your tensor contains. We have a lot of conversation about dimensions of our tensors, and of course there is a method for get a number of dimensions. You can see it here, and also there is same useful other useful methods like size and null for get number of elements by each dimension, and number of all elements. For example, sometimes it needed to change our dimensions. First of all, we get the current dimensions of our tensor, and after that, we, based on this knowledge, we can use the method view for change dimensions. Now, here is an example how just add one more dimensions. For example, convert row vector to column vector. Okay. You can always convert your NumPy arrays to tensors and back, but you need to remember that during this process you don't make a copy of your data. You just use a pointer for the first data. So in this case, in this example, torch tensor points to numpy array, and back to numpy array points to torch tensor. Question: how back to numpy array will change if we will change the first element in numpy array by index? What happened?
Sorry, can you repeat the question?
Yeah. In this example, you can see that first of all, we created a numpy array. After that, we convert this numpy array to torch tensor, and after that, we convert our torch tensor to array, so which is named back to numpy. So now, if we will change the first element in the numpy array, yeah, by index, like here, what happened? This array vector array. The array vector array is changed or not?
Yeah, it will be changed, I think, because they share the memory.
Yeah, it is true, because we use pointers in this case, and don't copy data. So, and also we can return list too. Okay, I said that there are many useful methods and functions in PyTorch, yeah, like in NumPy, like min, max. We can make dot product and can multiply our matrices too. So yeah, you can use all of these functions for make your development process easier. So, okay, the second very important part in PyTorch is a dataset class. Yeah, always when we want to solve some real-world task, we need to have some main parts, some main things. Dataset, we need to understand what architectures we want to try. We want to define our loss functions and also how we will understand the quality of our model. So if we want to use PyTorch, we always need to wrap our data using PyTorch dataset class. For that, here you can see the simple example how you can do that. You always need to define two methods. First, it is len, how you can return the length of your dataset, and get item. It is a method for get element from dataset by index. So now a really simple example. We just say how many elements, points we want in our dataset, create our X, create our targets as just values of sinus function, and define these two methods, like just return the length what we defined before, and just return the element from X by index and from our targets by index 2. So, and you can see that how it works if we get some elements by index, and when we want to know the length of our data set. Of course, this it is a really simple example, but in this manner you can wrap your data set. For example, in the method init, you can read your data from files and something like that. So also you can see that here there is a parameter transform, and what is it? Always in PyTorch we are applying some preferences in our transformation for our dataset, and in Torch Vision, Torch Text, for example, there are a lot of different transformations for different data. So, but of course, we can create our custom transformations. We need for that we need create class with the additional method call, and and say how we want to change our data. For example, here we create a really simple transformation. This transformation shifts our data, our X values by some value. Default is 1, and yes, we can create the example of our class and get this type of transformation to our dataset class. And if we, for example, get an element from our data set by index, this transformation was applied, and we get not we get not 1 as well as the x, but now 0 because we made +1. So, and of course, in the many cases, we don't want to use only one transformation. We want to use the pipeline of transformations, and this task, the class compose can help us. So you just can create a list of your transformations and wrap using compose class. And yes, in the same manner, we just give this pipeline of transformations to the parameter transform in our dataset class. Okay, but there are a lot of datasets in Torch Vision library, for example. You can use these datasets for your experiments, these different architectures. So now we, on this seminar, we will use Fashionist dataset, and for using that dataset, we need to download this data from from internet, and you can do that just by initializing new class, new dataset class using Fashionist class. So it is really useful when you create, when you make experiments to split your dataset to train and validation, and create two different example of class for these two different parts of your data. Yeah, and because we need to treat this dataset a little bit in a different manner. For example, here you can see that the train, no, not here, one step later, yeah. So here we just create the example of dataset class for train data and for validation data, and said what kind of transformations we want to use. Okay, I think why we want to use transformation to tensor is understandable, but after that we also added some other transformation for normalization our data. So I want to remind that we want to use neural networks, but at the first step we will try to use the logistic regression model. So based on this information about our plans, why we make this type of transformation, why do we want to normalize our data before training process? Guys, why do we use normalization of our data before we start to train logistic regression models or neural network models?
It's because, like, if we don't normalize the data, the magnitude could be very large and it would cause problems with convergence.
Yeah, so we want to use linear models, yeah, and yeah, I think you know from your lectures that linear models like normalized data. Yeah, you're right. Thank you. Okay, we created classes for our types for our parts of dataset. After what we want on the next step. When we are training our models, we use some optimization process and update weights of models on each step, but we make these updates based on values based of the value of our the from sorry based on the value of our loss function using batches. Yeah, and so if we want some data sets, we need to select randomly some samples from our data set. Yeah, these random samples are batches, and yeah, we need to make predictions for by each batch, and after that aggregate all values from each examples from our batch, and after that make the step of optimization. So of course we always can write this process by hand, but in PyTorch there are the class data loader. This class helps us to make this iteration process. Yeah, we need just wrap our classes for our data set. Yeah, using data loader class. And yeah, in on this step, you start to treat your parts of dataset in a different manner. For example, in when you create a train loader, you say that you want to shuffle your data, but you don't want to shuffle your data in part for validation. Why? Guys, why do we shuffle our examples in during the train process, or make the different batches in each epoch, but we don't shuffle our items during the validation process?
Shuffling allows for more exploration by the agent, and it prevents like overfitting of the data, but we don't need to do this in evaluation.
Yeah, exactly. Because sometimes there are same anomalies, same maybe same wrong data examples in our data, and if we get batches in different combinations, we can smooth this influence of our wrong data, for example, and yeah, it can help to overcome overfitting. Yeah, thank you for your answer. So we remember that when we create data set, we need to initialize the pipeline of transformations. So, and after that, we wrap our data sets using data loader. Data loader shuffle our data and split our data set to some batches. So, question, when do we apply our transformations to our data? Before before split into batches, or after? So we get some data set split to two different parts, train and validation. Create create classes for each part. We give the parameter transform to each class, and this parameter for initializing the pipeline of our transformations. And after that, we wrap these classes using data loader. If we start to iterate but by our data loader, we start to iterate by randomly selected batch. So in which moment we apply our transformations? When we create our dataset class for all data in our dataset, or when we start to iteration process. First of all, we select a random batch, and only after that we apply our transformations to each batch. Yeah.
Before batching, I guess.
So there is the different opinion in the class. Please share your opinions. No, in this case, we apply these transformations after we selected the batch. Why it is useful? For example, we want to add augmentation to our data, and if we apply all our transformation to all our data elements in our data set, we really increase the memory for saving a new data set with different other elements after transformations. But in this case, we don't need to use a lot of additional memory. We just select a little batch and apply all our transformations for our data. And and after that, we can use this transformed data for one step of optimization process. For example, sometimes our transformations have a random nature too. For example, some transformation can make a random rotation. Yeah, when then value of for rotation selected select randomly. And yeah, in this case, we can add some additional randomization to our training process, and yeah, try to decrease our overfitting tool. So yeah, you need to remember that all your transformations in this case applied only after selected the batch. So yeah, we downloaded the images, grayscale images with different types of clothes, and now we want to try to train the simple models for solving classification tasks. Yeah, we have 10 classes of 10 different types of clothes. So here a little bit how can view a simple neural network with only one hidden layer, and we can remember that it is really similar this the logistic regression. Yeah, I can remember about the model logistic regression. This model have a parameters and bias, and we make this make linear transformation from one space to another, and after that we apply sigmoid function to our outputs, yeah, and make the prediction, make the predictions. So logistic regressions is a really simple part of neural networks. This is a dense layer, but of course in neural networks we don't use sigmoid functions as activation function, but the logic, the architecture is the very same. So for binary classification tasks, we use binary cross entropy, and you can refresh in your mind the step of optimization process. At the first step, we get gradients by our weights, and after that we use gradients methods for training, and change our weights. So yeah, we can now we can image the logistic regression model as a simple neural network. This one hidden layer and the sigmoid like a non-linear function in this case. If we want to solve multi-class classification tasks, we need to change sigmoid function to softmax and use cross entropy loss function too after that. Yeah. Here you can refresh the representations of softmax function and how we can write this model using matrices form. And yes, as a loss function, we will use the categorical cross entropy function. Okay, you can after to see in this table what changes we need to do for transferring from binary classification to multi-class classification tasks. And now how we can create this simple neural network using PyTorch. Yeah, we need to initialize the list, the sequence of our layers. Here it is only one layer. And after that, we need to initialize the sequence of how we want to transform our example in the forward phase. So, and yeah, we first of all, why do we need to use this line in our code? For what? What do we do here? Okay, this method, we remember that all our examples in our data set
I think it's flattening it so that the it could be used in the processing layer.
yes, this line just change the number of the dimensions of our examples. now we remember that our dataset contains the images, the 2 dimensions matrices, but yes, we don't have we can't to use images as 2-dimensional matrices for training. Yeah, because we don't know about convolutional neural networks, and we can use only dense layers. And dense layers can use only vectors as elements, as items for transformation. So yeah, and we need to, here we just need to change the number of dimensions of our items, and yeah, just flatten. But we can use this as transformation, as a some transformation. So if we go back to our data set, yeah, here, for example, we can add one more transformation like that. And if we will use a flatten transformation here, we don't need to change the number of dimensions in the forward step. So yeah, you can do that in the different ways. Yeah. How do you prefer? Okay. I mentioned that we can use GPUs for training our models. So yeah, here the magic line for define device for processing your data, for training your models, and when you created the model, you need to push your model to device. Yeah. If you have a GPU, in this case, your model will be trained on using GPU. If not, yeah, you will use CPUs. Of course, you always can push each tensor to GPU. But why we prefer to use this line of code instead to push all your data to all your data, all your weights to GPU using just point CUDA method.
Maybe the GPU is not available.
Yeah, if we try to use your code on the device where there isn't a GPU, yeah, your code will be crashed. So it is just for make your code more usable for all devices. So yeah, we initialize our model, push this model to device. After that, we need to say what loss function we want to use and what criterion for optimization we want to use for training our model. So yeah, now it is a cross entropy loss and stochastic gradient decrease. So pay attention to our model's architecture. So in the forward step, we just firstly we flatten our items, and after that apply our line layer, just map our data to other space using linear transformation. But here we don't see the the sigmoid functions or softmax or some other non-linear linear transformations. So, and yeah, and after that we mentioned just cross entropy criterion. So why we don't use some non-linear transformation here? Not here, not after. So what happened? So yeah, because when we mention what type of loss function we want to use, this class contains softmax and loss function. So we don't need to apply the non-linear function in our class for model. Yeah, because in this case we will have wrong computations. Yeah, because softmax contains in a class for cross entropy loss. You need to remember about that. And yes, the train loop, train validation loop. So we will have 10 epochs, and in each epoch, we first of all we need to say that now model is in training settings, and it means that we need to compute gradients. So yeah, we start to iterate by batches using example of our data loader. So yeah, for each batch we need to get outputs, apply our loss function for outputs and targets. After that, we can compute gradients using method backward, and after that we can make the step of optimization. Really easy to write this process using PyTorch. So, and if we want to validate our model during each epoch, we need to say that now our model in evaluation settings, and we don't need to compute gradients. Yeah, it is important. So yeah, this is a standard loop for training validation process, and yeah, also here you can find the function for drawing different plots, and yeah, I don't know you used before the library Plotly or not, but it is a really cool library for yeah, for drawing figures. So try to use it if not. So yeah, here we can see 2 lines for how our loss was changing during different epochs. So, and yeah, we can see that the line for train is really smooth, but the line these values values in from validation step not so smooth. So what happening, and how we can change our training process for making the loss, the line for loss in the validation stage more smoother. Now I show you how now we train our model. Yeah, here criteria for yeah, here the loss function, and here how we will how we change our weights, what we use for that, these what parameters, and how do you think what do we need to try to change or make make our training process more smoother?
We can reduce the learning rate, maybe.
Yeah. Now we have a really high learning rate, and we have a really big step when we try to update our weights, and yeah, so we can go away from our optimum. So yeah, for make this iteration process more smoother, we can try to reduce the learning rate. Yeah, always think and remember about your learning rate. So why we want to use more layers? Yeah, here I mentioned for you some problems which we can't to solve using one layer neural network, and for these tasks we need to generate more complex features from our existed features, and only after that we can split classes using linear linear space. So yeah, please will read this information after, and there is very interesting website for have a little play these different type of neural networks. Yeah, here, for example, XOR problem, and we can see, we can try to solve this problem using one layer, and yeah. And we see that we don't have a lot of, we don't have a great result. Yeah, we can try to reduce. But for example, if we add some non-linear features, we can reduce, we can split data in this task maybe better. So yeah, here you can find different tasks which you can't solve using only one hidden layer, but you can solve using different layers, or edit the complex non-linear features. And yeah, we'll play and try to separate these two classes. So have fun. Okay, now we try to add more layers to our architecture. So yeah, let's try to add one more dense layer, and yeah, you see that we add non-linear function between our two dense layers. So in the many cases, you don't need to use sigmoid function as the non-linear function between your layers. You need to use ReLU for that. I think you had a lot of information about that in the lecture. Please refresh these knowledges. It is really important. And yes, remember that the standard non-linear function now it is real. And yeah, you can always start from this function, but after that try to change, try to use other, like leaky ReLU, for example. But yeah, you need to remember about your data and what we want to get after your layer. For sometimes there are some boundaries, and based on these boundaries, you need to use tangents, for example. Yeah, which the non-linear function you will choose based on your task. Remember about that. But the standard it is a ReLU. So yeah, we added the second layer. Try to see how our how quality of our model will change. So yeah, we can see that we have a little bit better solution after adding the second layer, and yeah, our the loss function during validation, yeah, now are more smoother. So there are two main techniques for regularization. First, batch norm and dropout. So here I add the information how we make batch normalization. So let's refresh knowledges after. So, how do you think? Why do we use batch normalization? So, guys, try to remember information from. Yeah, I see the answer in the chat. Yeah, you're right. So, yeah, we can remember that linear models like normalized data, but each block in neural now each each block in neural network, our neural network is a linear model, and yeah, it can be really useful to normalized data before the next uh, linear model in our architecture for keep distribution. So yeah, we can add batch normalization after the first linear layer before our activation function. Yeah, it is really important. We need to normalize our data before applying activation function. So yeah, and you can check how the quality was changed. So yeah, we can see that our loss started to be less during on the train data, and maybe we have potential to make our the value of our loss function on the validation part less. Yeah, have some more epochs. So yeah, but also we can try to use dropout. Dropout, it is just about add some random process to our architecture, and yeah, we can try to train the second linear layer based on not on all features, based on only the part of our features, just by selecting randomly half of our features. Yes, and it can try to decrease overfitting too. So yeah, we can see how it can help. So not so much, but we can see that this technique made the loss on the validation part more smoother. Yeah, it is a good result for regularization technique. So, and I want to ask you the last question. So we, of course, we use dropout during the training process, but do we need to use dropout during validation or when we predict something? Yeah, do we need to use dropout during validation or test?
No, because it's used for regularization.
Yeah, exactly. You need to remember that dropout we use only during the training process because it is really strange to make predictions based on only half of all features. Yeah, we don't need to do that. So yeah, and the last thing what I want to say, please make save your examples of models during your training process. For example, yeah, um, for example, if you can save your model each couple of epochs. Why we need to do that? Sometimes something could go wrong, and your code can crash. And in this case, you don't lose your results and can start your training process again. And also sometimes, of course, we start to overfit and can see this on our figures, but um, it is cool to have a chance to get the example of your model before starting or before when it started to overfit. Yeah, it is really useful, and there is some functions for that in PyTorch. Please use that and always remember about checkpoints. So thank you for your attention.
Thank you.
Thank you for the lecture.
Thank you.
Thank you. Bye.